So first of all, wow, thank you so much for everyone coming out to hear my thoughts about the future or whatever. I'm sorry not everyone has a place to sit. I hope that this is going to be really interesting. I guess we'll all find out together. So my name's Matt. I work at Uber. I work on a lot of back-end infrastructure and stuff like that. And so I've been there for a couple years and learned a few things, and I would like to sort of share with you a little story. So a while back, as you may have known, like Uber has been growing a lot. And in the process of this, we hired a lot of engineers. When I first started 2 years ago, there were about 200 engineers. And now we find ourselves 2 years later with about 2,500 engineers. And so that is more than 5x growth year over year. As you can imagine, that's not very common or very easy to sort of incorporate that much new talent so quickly. And like all good engineers, they wrote a lot of software. I mean, otherwise, why hire engineers, right? If you're not going to write a lot of software, that's why you need them. So they did. We got them, and they really wrote a lot of software. And much of that software, on the back end anyway, was deployed as services. So you can call it microservices if you like. I mean, playing buzzword bingo or whatever, you can tick it off a few more times. But they're services. Here's the total count of services in our deployment system. And you can see that it's going up fast. And I didn't really start at zero. That's just kind of prehistory, where before things were actually in the system where I can keep track of this. Eventually they all got migrated over to, and so that ends up being the very real number on the right. So this is like a lot of services. And so here's a dashboard of that we're sort of tracking. I took that this morning, so that is the latest, freshest, up-to-date number. This is from the instrumentation team, who is trying to sort of make sense of this this whole service-oriented architecture, this big swath of microservices. And as you can see, not even everything is instrumented, but the important stuff is, right? And so I say all of this to sort of establish that we are way down the road of building out microservices. We have embraced it big time. And as you probably heard, you may have heard me talk about this, other people are talking about this, they cause a lot of problems, right? Like breaking up a monolith, it's like the cool thing to do, but once you have it broken up, then it causes a new set of problems. Like it's hard to debug, and it's hard to understand the system as a whole. Now that you've broken it up into these same parts, these trade-offs work both ways, and it's harder to profile, et cetera. But some new kind of curious problems are emerging, which is maybe microservices make it hard to collaborate. I know that sounds like a bit of a paradox. I'm gonna leave that there for a minute and fill in a little bit more of the background. So if you take a step back, like why should we use microservices at all? Like I know it's cool. Everyone is talking about it. You cannot go to a technology conference nowadays without seeing every other talk is like something about microservices, and obviously we all agree because look at this room, it's filled. We're all pretty excited about this microservices thing. So what's so good about it? Well, maybe easier releases, I guess. You don't necessarily have to release the whole thing. If you make some change to some small part, you can only just release that, and releases are disruptive. That's that's when things break, is whenever you release them. So okay, fine, yeah, probably. I mean, I guess that's good. But like another kind of argument goes like, oh, it's more efficient. And I guess that there's some truth to that. You could scale out perhaps different parts of the stack. Maybe if you need more video encoders or chat socket aggregators, maybe you don't need to scale out the whole stack. You don't need 100 more copies of everything. You can scale out just the parts of the stack that you need more of. Okay, fine. But at the same time, I kind of don't buy the efficiency argument, because now by putting the network in between all these processes, you've added all this extra overhead of RPCs or queues or whatever it is you're using to talk in between them, and it's just a lot more. It's a lot less efficient for computers. So maybe efficiency, kind of, I guess, but I don't know, kind of not buying it. So scaling the organization, I think this is where we have come to at Uber anyway. I don't think we could have scaled our engineering organization as quickly as we did if we did not embrace a microservices model. And I think it comes down to this concept, like why microservices, like what's good about that, is it comes down to this concept of coupling, and specifically of loose coupling. And we have kind of a couple, or I have a couple of different sort of perspectives on this. In my previous company, Voxer, was a mobile messaging company. We did microservices as well, but there were only 5 of us, and we got to some pretty interesting scale. But we built microservices anyway. Of 5 engineers, we had like 20 services. But at the time, we were, it was kind of like a cultural fit for the team. We used a lot of open source. We produced a lot of open source. This kind of more modular, loosely coupled system worked really well for us. And we scaled different parts of the stack independently. And that was cool. But at Uber, I think it really was thrust upon us. I don't think we really had much of a choice. The early Uber started with a big monolith, and it took a long time to sort of break it apart. We're only just now finally on the other side of our kind of monolith adventure. And so that was a huge project, and I feel like we could not have done that if we were not more loosely coupled. Because we just would not have enough time to coordinate and plan and just sort of guide all the efforts of all these engineers. Another aspect that comes into play when considering sort of how coupled your system is the mono repo versus many repo debate. And at Uber, we are squarely on the many repo. This is a quick little check that I've just checked in a few times. There's no official tracking of this, but this is our internal Git repo. And you can see that as of a few days ago, there were 14,000 repos in our internal Git repo. And some of them are like configuration, and when you sort of go down this loosely coupled path, after a while you're like, well, sure, everything is might as well make a repo for everything. The configuration for my service is in a separate repo. Why not? A lot of people who come to Uber engineering from places like Google, where they have this fantastic mono repo and exquisite tooling that makes it all possible, they sort of pine for the days when they had all their single repo. And it's really interesting because I think I kind of do too. It sounds more elegant, it sounds nicer. It sounds like being more responsible software engineers. This just kind of seems haphazard and sloppy. But I think the way Google got there was spending a tremendous amount of time, and specifically engineering time. They invested heavily in building out their infrastructure, and it didn't just show up overnight. I mean, this took a long time to get there. So who knows? Maybe we'll get fancy tooling and get down to a mono repo. I don't know. I kind of don't see it happening. But anyway, so we built up this team, and we wrote a lot of software, and we counter the usual problems, and we've sort of come up with our own solutions to these problems that I think most people who go through this kind of scaling journey they encounter. Things like the databases are too small, so we had to build a sharded database deal, and it's kind of weird making HTTP requests that are just haphazard, willy-nilly JSON all over the place. So we're going to have to get serious about our RPC frameworks, and it's kind of hard to find all these services that are coming up and down all the time, 1,700 of them or whatever. So you have to have some solution for service discovery, and keep internally DOSing ourselves just accidentally. We got to put some rate limits in place. Okay, that's cool. And of course, the whole point of having this modular system is that things can fail independently and not take down the whole site. So we got to get some circuit breaking going, and tracing. Got to be able to understand this thing. And I showed you the dashboard earlier of the tracing team. And release management. It's to deliver on the potential of having all these microservices, teams need to be able to release their software independently, but that software is not going to release itself. There's got to be some kind of a infrastructure tooling that engineers can use to say how's my last one doing? Okay, I want to get my new one out there, be able to canary it and roll back if that doesn't work, and there's a whole set of infrastructure there. And so in general, I feel like we encounter these problems, and maybe we built a lot of custom solutions where there could have been other open source options. I don't know, maybe. A lot of these things kind of evolved out from under us, like while we were working on them, gRPC didn't exist when we started doing our thing, and so like we have our own RPC thing, and a few other examples like that. But I feel like in general we've gotten to a pretty good place at the infrastructure level. These are sort of like the basic, like you scaled up a bunch of microservices, like now what happens kind of problems. So thing is, now we're finding some new problems, and that's what I want to talk to you about. Is now that if you've scaled up a big microservices deployment, those last the last slide is like, okay, cool, you'll definitely want to get all that stuff done, but I feel like there are a bunch of new things we're going to have to figure out, and we're grappling with these now, and I'm going to explain our thinking around how we're trying to solve those problems. But I also want to work with others to figure out better solutions to these problems. So like, here's the deal. After we've gotten a lot of this productivity gains from allowing adding people really quickly and helping them be productive, we're sort of finding that momentum is slowing. It's hard to make progress. It's hard to make seemingly simple changes now that the org is bigger, but also things are spread out all over the place. It's hard to know where to make a change. Changes that seem like they should be fairly simple to make end up involving a bunch of different parts and owned by a bunch of different teams. And so I think that a useful way to think about the problem here of this big deployment is one of composability. The microservices, I think the idea is that we have built these Unix kind of pipelines with text interfaces, and you can sort of mix and match them, swap them out, and do one thing and do it well. And my experience is that's very hard to do with microservices that are swapping objects with types and running logic on them and talking to databases, and it becomes very hard to construct that kind of composable pipeline. But I think we've, at some level, this is not a new problem, right? This is reusing software reuse. I mean, it's been around since forever. It's like always harder than it seems like it should be to reuse your software. I think the difference that we have now with a lot of microservices is we've added a service boundary in between, all over the place. And if your change cuts through that service boundary, it might, it makes it harder because you got to go work with some other people and sort of get in their release schedule. But B, it makes it be, it opens the opportunity that maybe you'll just write some new software. Like maybe it's easier just organizationally to write a new service as opposed to going through, tying your schedule to everybody else's schedule and figuring out how to do these cross-cutting changes. It might actually be easier for you to just write some new thing instead of fixing the old thing. So this is kind of a new angle on software reuse, which is we've moved the cost levers around a little bit. All right, so I'm going to show you this, to make it a little more real. I'm going to show you an example of a flow at Uber. Now, this is a super simplified version of how Uber works, and any Uber people who are watching this, I know those lines don't necessarily connect to each other, but there's no way to put a meaningful set of boxes on a slide that would have all the right names and all of the correct thing. Conceptually, it kind of works like this. And it sort of serves to explain the situation here. So imagine you've got a mobile phone and it's talking to we have this API layer at the end. It's called RT API. And if you want to get picked up, you're like, pick me up here. That request goes to a service called demand, which manages the state machine for the marketplace. And the point of this marketplace is to match up supply with demand. And that demand uses a bunch of different services to get its work done. It goes off to Optic to figure out what things you're allowed to see. So what products are available in your area and how much do they cost and what icons do they use and all that kind of stuff. And then GeoBase is a geospatial index, so find the nearest vehicles to you. But it also filters down by your product requirements. So you're like, I want an Uber X, but whatever. All the different ways of filtering down the product sorted by distance from you. And then Disco is kind of the routing engine that decides based on various other services that are not pictured here, what the best vehicle really is that we want to dispatch. And then supply runs the state machine for the other side of the marketplace. So to give you a sense of, I mean, these are some kind of core services that are working in here, but what those gray boxes and kind of like surrounding this whole thing is a absolute swarm of other services. And just to give you a sense of what that looks like, I went into our, the tracing team has a thing that of the services that are traced, they will draw a dependency graph, and I scrolled around on it this morning to find RT-API. And so there it is. Whoops, missed the mouse there. And then up here, whoops, and up there is our user service called Populous. I'll talk about that in a second. But you can see like there are a lot of lines going a lot of places. And so that's what it really looks like. Okay, I mean it's not my little thing with the 8 orange boxes or whatever is to just to break it down so it's simple enough so you can understand. This is sort of another view of RT-API. This is from our anomaly detection system. It's the best graph I could find where you could actually see like the count by one service. So ignore the colors; those just mean something's a little weird along that path. But that big red dot in the center, that's RT-API, and all the things on the right, those are all the downstream services from it. And like here's Optic. So like there are a bunch of downstream things from that. So wanted to give you a flavor, like it doesn't really look like this. It looks like that whole crazy world, but there are some, pretty important, some of those parts are more well, trafficked and scrutinized than others. Okay, so imagine you have this thing. You have this setup, and you're dispatching people and you're matching up rides or whatever. And you want to add some new products. You want to deliver food or route autonomous vehicles or put some cars on the road that have puppies in the back. Like, I don't know. There are a bunch of different ways in which you might want to change the system and like how it works. So let's take the puppies example. Like you want to put some puppy cars on the road. That's cool. So there are suddenly some new rules. Like the puppies, they're from the pound, and we don't want them to go too far from the pound, and so we got to put some like different kind of weighting on like where the people want to go and how likely is it that they're going to stay within the range. And next thing you know, you have to change some of this other routing logic because it turns out there are a bunch of other things about like, well, the puppies can only actually be on the road for 2 hours and they have to pee. So then like we got to figure out some other stuff there. And then we got to ask the users because it turns out some people are allergic to dogs or just don't like dogs or just not into it. And next thing you know, we have changes all over the place to implement this very simple thing of let's put some cute puppies in a car and people will love it. And now we got to work with all these different teams. You got to touch all of these really important services that are critical to the business just for your fun little puppy promotion or whatever, right? So you can sort of see how, because all of these are often team boundaries, that the puppy team has got a challenge. Like, it takes a lot of effort to implement puppies in this world. And I think that's because these systems are not composable. There's no easy way to just add in the puppy logic. And I think that is the world that we want to live in. We want to be able to have these, have the benefits of this, very modular system, granular deploys and, teams on their uptime, et cetera. But we want to be able to implement new features without having a massive cross the company, architecture designed to implement a puppy situation. So here are some things that we're working on. These are all kind of works in progress, but some are a little further along than others. But these are general ideas we have around how to make this better, how to make this whole thing more composable. So the first thing is, a bunch of these services and a bunch of the complexity comes from the fact that a lot of these services need storage, right? So you wouldn't have a proper microservices deployment if things were sharing databases, right? Like that would be crazy. No one wants to share a database. sort of the first thing you learn in microservices school is like you can't have shared databases. So fine. So services want their own storage, but man, we got a lot of services out there. And so you can imagine that's a lot. Now, you don't all need storage, but that is a lot of different storage installations that we have to manage. And because everyone wants their own storage and they want to kind of own their, own some part of the data model, right? The user service, for example, like if you want a user, you got to go out to the user service. And so this is the user service. And so that to the left, I can't see the line, but to the left, those are all the things that consume the user service. So everybody, not everybody, but a lot of things want to know about a user. And so in order to know about a user, they had to reach out to the user service and figure that out. So this is hard to cache, first of all. Like obviously, if every time you want to know about a user, you always have to ask the user service. But it puts this really big burden on the user service as well, that now they have all these customers and they all want to know about user. And it's very, very hard to make changes in the user service. If you want to change something about, like, add some new properties to a user or just, I don't know, change how users work, you got to potentially coordinate with a lot of customers. And so developing against the system with all these services and all the storage is very hard. You can't spin up the full stack just for you, like even if you want to. Like you can't just say, I got a nice new laptop, I'm going to put the whole thing on there. Like it simply does not work. So it's not even just can you get all the software running all at the same time, which you can't. It's also the software doesn't make any sense unless you have access to the data. So there are a whole bunch of stuff in various databases that kind of all work together to make the thing work right. And if you're a developer and you're trying to make some change and you want to validate that it's working, you have kind of a challenge, which is how do you test it in a realistic environment? And a lot of what makes that environment realistic is the data that's in these databases. So we had some, one more thing. And so like I said, if you're the user service especially, and you want to change your, you got some new customers and they need some new field or they want to change the way something works. You want to change your schema. You want to change what kind of user objects you return for these queries. And it's a real challenge if everybody's depending on certain aspects of your data model. And it gets worse because it's not just your direct consumers. Your direct consumers are perhaps all the way to the left of service A, calling the user service with their RPCs. But chances are you're also putting putting these objects into a message queue. And there are some services that consume it via PubSub. Maybe they're on the end of some Kafka or RabbitMQ or whatever. And you probably got a data warehouse too. Like all these objects, these user objects are like all flowing into something. So you can run your BI or whatever. And so your schema changes now are suddenly very, very complicated because you got consumers upstream and downstream and just all over the place. It's tricky. So we set out to work on this project. This is one that I've spent a little bit of time myself personally working on. And we had some goals, which is I wanted to stop having the conversation of if we have a lot of services, like it's somehow bad. Like once you get past, 10, I want to add enough automation to make it so that it doesn't really matter how many services you had. Like I think if people said, wow, you sure have a lot of libraries in your repo, like no one would say like, oh, too many libraries. But somehow saying too many, if you have 1,700 services, like that sounds really bad. But I think lots of people have 1,700 libraries. So I want us to get to a world where the actual number of services doesn't really matter. Provisioning services, like engineers should be able to just get storage. They shouldn't have to spin up a cluster and figure out all the details around that. But more importantly, they should be able to safely test with real production data. And this is a real controversial goal. Still, not a lot of people are on board that this is maybe possible. I think eventually most people get on board with this is probably a good idea if you can do it safely. But safely is right there in the line. So like I only want to do it if we can do it safely. But this is this is super powerful. If you can safely work with production data, I think you can write better code the first time, and it's sort of easier to sort of get your changes get your changes in there. Fancy types, by that I mean types like location or phone number or email address, things that programming languages don't generally have. And if you're serializing out to to Thrift or Protobufs or whatever, these things are often lost, and these richer types I think provide a lot of value. So we built a system. We built this thing called dosa. It's a clever acronym. It doesn't really matter what it stands for, but we think it's quite clever. And so here's the way it works: is you've got this library inside of your service. So your service A, and you know that you want to you own some certain object. Like you're the user service, let's just say. And so you define the schema for this user service, and you've got this library. And when you start up, you find the dosa service, and the library negotiates the schema and says, hey, look, I think that users look like this. I think they have all these fields, and I think that here are the things you can do to them, and you buy that? Like, is that going to work for you? And they, as long as there's some way that both the library and the service can read and write each other's objects, then we're allowed to continue. And so we register the schema in the schema service that's used both by dosa and by other downstream components. And then on the back are a couple of, I don't know, it doesn't really matter how many there are or even where they are, but there's some storage. It happens to be Cassandra in our case, but it could be whatever. We happen to want to separate out the dev users into their own cluster, but fine, whatever. And so how do we get to this kind of magical state of allowing developers to safely work with production data? Well, we have an RPC gateway that if you are on your laptop or you're on some dev server or whatever, we have a SSH authentication scheme, and you write the same code, but when you talk to prod, you go through this RPC gateway, and then your RPC has some context associated with it. And that context is what allows us to do some interesting things, which is we have this idea called storage scopes. And a storage scope allows you to implement a sort of copy on write layer toward your database, your storage, whatever you like. And that's the magic. That's how we allow developers safe access to production data. So when reads come in, like if a dev user has this scope list and it says, the scope is MJR and then prod. So first, reads will always go to, the reads cascade through the scope list, but writes always go to the first element in the scope. So you can read, you're looking for U1, and you don't find it in the MJR scope, but you can read the prod version of U1. And then if you write some U2, it always goes into the top level scope. And this doesn't have to be two. It could be some long list, like maybe you've got some team, the MPX team, and they've got some fixtures or whatever that they're all kind of working on. And so the reads can cascade through a scope list, and that way, that way we can safely not only work with production data, but the team can stage up some pre-production data before it actually gets released. And of course, in order to support the schema evolution process, the scopes also have schemas, so this allows you to safely test schema changes, because you can drop a scope. If you decide you don't like what you did to it, just kill it. It's copy on write, no big deal. You'll start over from the underlying layer, so you can test evolving your schemas without worrying about breaking anybody else. So that's pretty cool. And so what we find is that we're able to add a sort of encapsulation layer to our objects, and this encapsulation layer allows us to transit other systems that don't necessarily know about our schema. So the things that we store in the database are opaque blobs, effectively, and those opaque blobs can be transported through a message queue, perhaps, and come out into some service B, which uses the library that we provide to extract these values and interact with them. But this is sort of a way that we can get some amount of composability out of our storage systems. that we don't have to teach the message queue, for example, about our schema. It doesn't have to be aware of schema evolution or any of those problems. So it's a step. And back to the user service problem. The user service can now start shipping around a user library. Like users don't, users of the user service don't have to know, like, I better make this RPC to the user service to find out what a user looks like. They import the user package and they sort of make their, they make their requests. And of course, that's how we can get caching and all the rest. So we're back to this thing. There's another sort of tricky problem here, which is the demand service in this case, the supply service. There are actually others like this where we have state that needs to be coordinated. And now we've gone and we've broken our whole thing up into a whole bunch of different microservices that all own their own state. But sometimes we actually need to coordinate. Like we want to assign a job, or especially like in the Uber Eats case, it's even more complicated because there's like inventory to manage and all this other stuff. And the way that we are working on solving this problem is by implementing the Saga pattern. And if you're not familiar with this, you should check out Katie's talk. She's talked about this quite a lot. But the basic idea is if you make these long-lived transactions that might involve multiple different entities, and for every action you take, you supply a corresponding like undo action. And there's a coordinator that kind of advances things through the state. And this is a really good idea if you have things that need coordinated state. And the tricky bit that we're kind of grappling with is how can we implement sagas but allow teams to change the flow, change the elements of them, and not have to have full 100% coordination at the team level. Like how can we make a pluggable Saga framework? And this is an active area of development, and if anyone else is working on this particular problem, I would love to chat with you about it. So coming back to the biggest one, I think, is that we got all these services, right? And they all talk directly to each other. They all know about each other. The way that you want to get something out of some other service is you make an RPC to that other thing. And if you look around, especially if you ask people in academia or just people who have been in the industry for a while, they will tell you like RPCs are a terrible idea. Like why are we relearning the same things like every 10 years? Read this Chris Micklejohn blog post here, as well as he's given a couple talks on it. It's super good. It cites all these references and just shows how like we keep running into the same problems like again and again and again. Like we wish local computing and remote computing were the same, but turns out they're not. And they're just fundamentally not the same. And as much as we try to make them be the same, like they fail in different ways, and they're just not. So the conclusion always comes down to, what we should have instead of RPC is we should have asynchronous message passing. Like that would be way better. And I guess so. Like my conclusion is probably, like, I don't know, I think. But asynchronous message passing alone does not give us composability. And I've really been struggling with this lately, and there's something funny going on here. Like why is it so hard to change the behavior of the system? And there's a quote at the end of that RPC, the RPC post, that's like the closer quote, which is like, does developer convenience really trump correctness, scalability, performance, separation of concern, extensibility, and accidental complexity? And I read that and I'm like, no, come on, those things are great. Like I want all of that stuff. But then I started thinking about it and I'm like, there was a time not too long ago, I don't know, maybe like 2 years ago, where I probably would have had a different answer. Like I probably would have chosen developer convenience. That's interesting. Developers are really expensive. So like when you don't actually have all those other problems, you tend to optimize for developer convenience. So let's say that we converted all of these RPCs and we made all of these RPCs be asynchronous messages. Okay, cool. I don't think that necessarily fixes this problem. Like we still have the challenge of if you want to change how these things are assembled, there's no kind of obvious way to do this to make a cross-cutting change. So let's zoom in like on one particular interaction. So like the demand service sends an asynchronous message, not an RPC, to the geobase to figure out what are the closest vehicles. It uses those results, and it says, hey, Disco, listen, what's the best? It says who has the lowest ETA, but it's obviously many, many more dimensions than that. And it turns out, for the current situation, the answer is puppies. Like, puppies are closest, congratulations, you win. Problem is that user might not be into it. And so what we want to do is we want to have the puppies team be able to add that little block right there, not touch anything else. Like not tell the routing team, the DTA people, and the Disco people, and all this stuff. They want to just stick a piece of code right in there that says, hey, wait a minute. If you're ever about to dispatch puppies, make sure that the user's into puppies. And it sounds so simple, but there's no obvious way to do this in this kind of the microservices RPC or async messages or whatever kind of framework. And I think the world that we want to live in order to sort of have that kind of flexibility, is instead of services, I think a better model is one of composable event processors. So these are things where we would pass an object along with some action, and then there is some other way of orchestrating those things together that is, I don't know what it is. Like maybe that's the next generation of service discovery, maybe that's some kind of workflow thing. Like, I don't know. I mean, these ideas start sounding kind of similar, right? Like maybe am I talking about like Amazon's workflow and Lambda thing? Like, I don't know, kind of, but they're still lacking the composability, and not to mention it's like way too slow. So like we would never be able to get the kind of throughput that we need. But they'll probably fix that, right? Like they'll probably make it fast eventually. But what does service discovery look like in a world of composable event processors? Like, are you discovering a service? Like, that's kind of the problem. Like, the problem is we had to know who was on the other side, and service A has to know, service B, I want to tell you this thing, and then the puppies team cannot wedge their code in there. And so I guess that's like service discovery. Like, I don't know. It's really, really complicated. And I think super powerful, but I want to take a really big step back here for a second and ask, why in the hell do I care about any of this? Like, I work at a transportation company. I do not work at a future of computing company. Like, this should not be our jobs. Like, we should not have to be building this infrastructure. It's not our product. And I would bet, other than a few of you, most of you are not in the business of sort of building these low-level components either. Like, I don't know, maybe you work for a cloud provider, and that's cool. Like, cloud providers may eventually, figure this out, but it's weird. Like, how come there are no obvious solutions for fixing this problem? So I think it comes down to the fact that the tools that work for building small. Like you're just getting started, you're like, I got a Python thing and I'll just make some, Postgres and HTTP, it'll be great. And it is great. The problem is that the tools for building small stop being the best for building big, and the tools for building big, they just make no sense if you're building small. And in fact, people will yell at you if you say like, well, I'm worried about maybe I'll have scaling problems in the future. Like you will get seriously yelled at, and people will say, you're not Uber, you're not Google, you don't need all that stuff. Like it's weird. Like there's real rage about like pre-scaling, or even worrying about whether you might want to be scalable in the future. Like I'm actually not sure where that comes from, but that's sort of a different problem. Thing is, can't change the fact that the tools for building small are just simply better than the tools for building big. So what I think we need to do as an industry is we need to flip this. We need to make the tools for building big be just plain better than the tools for building small. Like for example, like copy on write storage. Like why is this not a thing? Like if you had, even as a one-person developer, you still get the idea that I would actually rather test with my production database. I mean, realistically, if you're one person, you probably do test with your production database, but like, what you would like to do is do that safely. You would like to be safely working with your production data, and there's no obvious way to do this right now. So, I mean, that's a example, but so the list goes on. And I think look, I think that the cloud vendors will eventually get here, but we need a vendor-neutral way of building systems that work this way, of building big systems that are built in such a way, even when they're small, that they're just better, so that if they need to become large, we can make them large. And it can't be controlled by one company. Like, if it is, it's never going to get the kind of industry change that I think we need to get here. So, yeah, I think this is the tricky problem, but I think it really comes back to this, like, does developer convenience trump correctness? Like, at first, it absolutely does. Like, who cares about all those other things? Like, at first. Like, at first, you are just trying to ship a product. You got to get something out the door. Like, you do not care about separation of concerns. You care about, like, am I going out of business? So all you care about is writing software. But then, after a while, you're like, well, developer convenience, I'd trade a little bit of that if I could have some of this extensibility or whatever. So I think that's just where we have to start. And I think a good way to tell whether we have achieved this is to look at our systems and to see how composable they are. That's all I have. Thanks a lot. So there is some time for questions if you have any.
Okay, thanks, Matt. I think we've got time for questions, so if anyone wants to put their hand up, I can run over. Oh, right here. Perfect.
Hi. I'm very curious on how your development environment looks like, and how do you can possibly be spinning several VPCs for containing all of those microservices together. So how is like your everyday work? You mostly work with unit tests, or how do you deploy on those test networks? How do you do that?
Yeah. So developers, developers have a limited subset of the whole system. They have enough services that they can kind of make something useful happen. But yeah, it's a lot of unit testing and integration tests. We're getting more and more of that done. But no, you can't have the full stack, and so you have to find a way to test just your part of it. And maybe it's clever curls or whatever, or maybe I don't know. But yeah, you have to find a way to exercise just the part that you're working on, because it doesn't fit.
Any more questions? All right, back there.
Sure. How do you guys handle the dependency during the release management? Like, this service needs to go live, and in order to get this service live, you need to have 5 other services to go live with it. And in order to do this, you have to break another 5, and the tree grows.
Yeah. So dependency management during releases. So it's obviously complicated. I think that the main answer is all releases have to always be rollbackable. So you can't ever move forward unless you can also roll it back if that's not working. And it might mean that in the scenario you described, it might mean that if there really is truly that much coordination, it might mean that to roll this thing out, it might take 2 weeks. Because you might have to roll this thing out and get confidence with that, and then do a few more things. Perhaps I would say that generally that makes people come up with some other idea. like if it's that hard, it better be really valuable for somebody to want to propose a change that's that cross-cutting. So typically what people do is, if it's really that big, is they'll spin up an entire parallel version of that path and then try to shadow traffic into it for a while. They'll build some kind of traffic shadower fork in their RPC chain and validate that whole new thing works. And maybe it's new versions of a few different services, but if it's that complicated, they'll pre-spin up a dark version of it. And then as soon as the results look good, then they'll they'll flip it over to handle actual traffic.
So you talked about... Okay, I have a question concerning versioning of microservices. Doesn't they help in the composability of microservices together? To which extent they have good impact or positive impact or negative impact?
So, but what would versioning mean? Like you have multiple versions running at the same time and you get to pick the one you like?
Yes.
I see. Yeah, we don't do that. We make changes. All the changes have to be backward compatible, and so you move forward, and nobody knows what version anything is. Like, I don't even know how you know. Like, versions are like a git hash and a date. You know, it's like, this is the version of the thing that we released the other day, and if you want to know what code that was, like, the git hash is right there, so you can figure it out. But yeah, it has to be backward compatible, so like nothing is versioned.
Okay, thank you.
So you talked about the composable event processor. Can you expand a little bit more on that? Do you have already something on it in the pipelines?
Yeah, this is the thing that we're actively working on. How we can. I mean, it sounds like a major change. So we're trying to come up with a way that we can be more incremental and get some properties some properties of a system like that. And it's still really early days. But I mean, I think something like that is where we have to go. I'm actually not sure what it will take to get there, or even necessarily like what the right abstraction is. Like, are you moving actions around, or like I'm not actually sure, but I know the properties that I want the system to have, which is I want to be able to implement things like puppies without changing any code, and we're just working backwards from that. Like whatever it will take to make that use case possible, we're trying to figure it out. And I mean, if you have ideas on what such a system could look like, we'd love to work with you. And like ideally, we would build some open source deal that does this. And it wouldn't have to be re-implemented by every company that scales up their microservices deployment.
Hi. Can you put up the slide where you introduced dosa? I would like to take a picture of it, to be completely honest.
Okay, the slides will be on the website. You can get the PDF and like in glorious high resolution.
Okay, thanks.
I mean, I'll put it up if you really want to see it, but this one?
That's the one.
Okay, super.
I remember you mentioned about using the production data in development environment and then copy on write. Are you guys currently using it? How is your experience?
So dosa is in production, but it's very early. There are only a few customers that are on it. I mean, it just came out like a few weeks ago. But so far so good. I mean, the no provisioning and the copy on write is a killer feature. And yeah, I mean, we'll ask me in 9 months, and I will know for sure how well it's going, because it's kind of non-critical things that are on it right now. We want to get it to be the point where most services are on top of dosa.
How do you handle transactionality and consistency across microservices?
Yeah, so that's where the sagas come in. We don't have, like, ideally, we basically discourage people from having that requirement. So we try to keep it within a given service. Then, if you truly do need that, then we have ways to do it. I mean, it's not all Cassandra storage on the back end, but generally speaking, anytime someone says we have this requirement that can only be met with a transaction, it's kind of like a red flag, because it's really hard to scale those. They just have operational properties that are not the greatest. So, but in the case where we do need to do, like, especially distributed transactions, like where we need to do things across multiple services that either work or don't work, that's where we're building sagas.
Any more questions?
I had a question regarding how do you decide, is there a playbook or a set of rules whether a certain new thing is part of a new service or an existing service?
Oh, yeah. So, right. No, I think it's just kind of up to the prevailing forces of like which people are available on which teams and where. There's not really a guideline that says services should be built like this. We kind of leave it up to teams to solve the problem however it is that they feel is best. So it's not always a new service. Like, a lot of times people modify existing services, but like, Yeah, no, we empower the teams to make their whatever choice they feel is the best.
If you have a situation where you're shipping libraries for accessing, say example, the user service to 2,000 other services, how do you deal with the versioning of the library to make sure that each of the other services is using compatible versions?
Right, well that's where this comes in. I mean, that is exactly the use case here, which is the dosa layer allows services to evolve and provides a schema evolution path. So that maybe there are old versions that have an old version of the library, but they negotiate a compatible version with the dosa service, so they can still read and write old objects even though they don't have the latest schema. But importantly, because we have this layer that is an active service, it's an active RPC, we can also now tell that people are using an older version. Whereas a big problem with library age is it's often hard to know if some of your users are calling you with an older version of a thing. But with this, we explicitly know.
Perfect. Thanks, Matt, and thank you all for attending. We're back in here in about 25 minutes with Josh Evans from Netflix, so please do come back. Thank you, Matt.